When people first faced the problem of how to show a picture on a screen, they had to come up with a way to break the image down into data. In 1957, an early computer engineer named Russell Kirsch took a picture of his infant son and scanned it. It was the first digital image, a grainy black and white baby picture.
But actually, if you get a magnifying glass and you go up to a screen, you actually can see that your screen is made up of tiny dots of little light. Pixels together from far away create an image. And up front, they're just little lights that are on and off. And the combination of those create images and what you see on your screen every single day you use your computer. So you'll hear the term resolution a lot, both in computer science and manufacturers of devices will talk about it. Resolution is basically, it is the dimensions by which you can measure how many pixels are on a screen. And then there's the question not only of resolution, but also of density. So for instance, on modern smartphones, they fit the same number of little lights called pixels, but in a denser space, and it's what allows you to get sharper images.
All computing and digital data are represented by bits. A bit has two states, it's on or it's off, but instead of on or off, computers use ones and zeros, binary. So an image file is actually just a bunch of ones and zeros. Turns out that each color channel, RGB, is represented by 8 bits, which together are called a byte. We could represent a pixel of the color turquoise, for example, in our traditional decimal-based number system as 64 for a little red, 224 for a lot of green, and 208 for some blue. So rather than binary, digital artists often use the hexadecimal number system to represent colors.
Basically, there are ways of mapping functions where you take the input value of the pixel, so you take an input of a red, green, and a blue value, which represents that color, remember, and then you map it using a function to a new red, green, and blue value. Let's say you wanted to make an image darker, right? One way of doing that is by taking the red, green, and blue values that come in, and let's just say subtracting a fixed constant from each of them. So subtract 50. Right? What you'll see is you take in an image with a certain brightness and you get out an image with a much darker brightness.